Simulan mong abutin ang iyong pangarap na magbibigay dangal sa iyong bukas. Ang suliranin hindi laging nandyan, dapat mong harapin. Kami iyong kasama sa bawat takin, magkaakbay nating lulutasin. Dito sa Fernandino Teens TV, ang boses mo ay mahalaga. Dito sa Fernandino Teens TV, ikaw lagi ang bida. Ang mga aral ay ginintuang atin ng bawat guro na siyang gagabay sa iyong pagkamulat. Naway umukit ito sa iyong isipan, maging mapanuri, sundin ng wasto at nararapat. Kagandahang asal ang ipakita, ipadama ang pusong may malasakit. Dito sa Fernandino Teens TV, ang boses mo ay mahalaga. Dito sa Fernandino Teens TV, ikaw lagi ang bida. Sakali mang tayo'y subukin ng unos, ating haharapin ng walang takot. Sasamahan ka ni Fernan at Dino, ang bagong barkada mo. Dito sa Fernandino Teens TV, boses mo ay mahalaga. Dito sa Fernandino Teens TV, edukasyon mo'y sigurado na. Dito sa Fernandino Teens TV, boses mo ay mahalaga. Dito sa Fernandino Teens TV, edukasyon mo'y sigurado na.
Fernandino Teens TV.
Nan, busy ka ata. Anong ginagawa mo?
Heto, sinasagutan ko tong modified assessment tungkol sa electromagnetic waves.
Ano ba yung mga yun?
Di ko nga rin maintindihan eh.
Basta ang alam ko, may kinalaman dito ang radiation galing sa araw, cellphone, at oven.
Parang ganun na nga.
Sige, para lalo nating maintindihan ang electromagnetic waves, panoorin natin ang episode ngayong araw.
Handa na ba kayo, Fernandino Teens?
Tara, let's watch and learn.
Hi there, Fernandino Teens. I am Ma'am Azeneth A. Romero, and I will be your teacher-lecturer for this episode. I hope you and your entire family are safe and healthy. Come and join me as we unfold yet another series of insightful learning. The title of today's edition of FTTV is Electromagnetic Waves, Its Types, Applications, and Effects. Before we go deep into this, let me first share something exciting with you. The last ruler of 5 great emperors of Rome, Marcus Aurelius, once said, "What doesn't transmit light creates its own darkness." Essentially, this only means that we always have to let our inner light shine, inspire people, and extend a helping hand to those who need it the most. Become optimistic at all times and stay away from negativity that abounds nowadays. The COVID-19 pandemic has brought so much changes in our life. Changes that tested our relationships, resilience, and faith. However, let us become each other's light and spread our radiance starting from our homes. Today's episode is in a way related with the quotation mentioned earlier. The topic of discussion will focus primarily on electromagnetic waves, which include visible light as well as the varying degrees of energy these waves carry. Before we begin, let us try to answer few questions about EM waves. You may write your answer in a piece of paper and later use this to initiate a meaningful discussion with your family. For those who are watching online, you may type your answer in the comment section. Are you ready, Fernandino teens? Great! Let us start. Number 1. Which of the following is the greatest source of radiant energy that supports all living things on our planet? A. Electricity. B. Nuclear power plants. C. The sun. D. All are possible answers. Very good, Fernandino teens. The correct answer is sun. The sun, just like other stars, releases vast amounts of radiant energy which makes life possible on Earth. Number 2. Which among the following household materials emit radiation or radiant energy? A. Cell phone. B. Microwave oven. C. Wi-Fi router. D. All are possible answers. Good job! All the given options produce or emit a certain degree of radiation. Number 3. Which of the following types of electromagnetic radiation carries the least amount of energy? A. Gamma rays. B. Infrared. C. Radio wave. D. UV rays. Excellent! The correct answer is radio wave. Among the 7 types of EM waves, radio wave possess the lowest amount of energy. After answering those questions, I am pretty sure that you became curious and it opened even more queries regarding our topic. Before we start going further into our subject matter, here are the objectives of today's lesson. At the end of the lesson, you would be able to first, differentiate the regions of the electromagnetic spectrum in terms of frequency, energy, and wavelength. Second, determine how electromagnetic waves become relevant to people and environment. Third, identify the consequent effects of electromagnetic waves. Radiant energy, also known as electromagnetic radiation, is the energy transmitted without the movement of mass. Practically speaking, this is the energy found in electromagnetic waves, also known as light. These electromagnetic waves are radio waves, microwaves, infrared, visible light, ultraviolet or UV, X-ray, and gamma rays. Light or radiation is made of individual particles called photons, each carrying a small packet or amount of energy. Examples of radiant energy includes the warmth that radiates from a hot stove, warmth from direct sunlight, and even the warmth from your own skin. All types of electromagnetic waves can be described through their wavelength, frequency, and energy. Before we proceed with these 3 characteristics of a wave, let us first consider understanding this illustration. As you can see, an electromagnetic wave is identified with various parts. Crest is the peak or the highest point of the wave, while trough is the deepest or lowest point. Amplitude, on the other hand, is the distance from the normal line going towards the crest and trough. Based on the illustration, Wavelength is the distance between identical points. In other words, it is the space among two successive crests or troughs and is usually measured using nanometers, centimeters, and meters. Wavelength is also expressed using the Greek letter lambda. The second characteristic of a wave is frequency. Wave frequency is the number of waves that pass a fixed point in a given amount of time. The SI unit for wave frequency is the hertz, where 1 hertz equals 1 wave passing a fixed point in 1 second. To make it easier, let us study this illustration. Which among these two waves has higher frequency? That is correct, Fernandina teens. The first wave has higher frequency compared to the second one, as evidenced by the number of humps between the two. If we are to count, there are more or less 12 humps in the first wave as compared to only 2 of the second wave. Wavelength and frequency are very much related to each other. When we return, I will show you an experiment that would explain the relationship between these two characteristics of an electromagnetic wave. Do not change the channel, and Fernandina Teens TV Season 2 returns.
Ang Schools Division Office City of San Fernando, Pampanga ay kaisa ng Department of Education sa pagsasagawa ng mga proyekto at programa na tumutugon sa mga pangangailangan ng mga mag-aaral. Inilunsad ang Division Call Center for Tutors and Guidance Counselors upang magbigay ng educational at psychological assistance sa mga mag-aaral, magulang at stakeholders ng division. Kaya, kung may nais kayong itanong tungkol sa pag-aaral, maaaring magpadala ng mensahe sa Division Call Center for Tutors and Guidance Counselors Facebook page o tumawag sa mga numero na makikita sa ibaba ng inyong screen tuwing Lunes hanggang Biyernes sa ganap na alas 8 ng umaga hanggang alas 6 ng gabi. Maaari rin kayong sumangguni sa ating guidance counselors na nagbibigay ng guidance and counseling services. Lahat ng inyong ibabahagi ay mananatiling confidential. Ang nasabing programa ay nagsisilbing daan upang malaman ang feedbacks ng stakeholders para matulungan ang ating divisyon na mapagbuti pa ang mga sumusunod na programa. Ano pang hinihintay ninyo? Tumawag na sa aming mga numero o bumisita na sa aming Facebook page at magpadala ng inyong mga katanungan.
Fernandino Teens TV.
Welcome back to Fernandino Teens TV Season 2. As discussed previously, radiant energy or electromagnetic radiation is the energy carried by electromagnetic waves. Basically, these EM waves are described according to their characteristics such as its wavelength, frequency, and energy. Using the given illustrations earlier, parts of a wave, wavelength, and wave frequency were also identified. This time, let us proceed with an experiment that will further show the relationship existing between wavelength and wave frequency using a PET interactive simulation. Get your notebook, take down some notes, and observe closely because later, I will be asking some questions based on the experiment that we are about to perform. Are you ready, Fernandino teens? Let us watch this.
Hi there, I am Ma'am Azeneth Romero saying, it's always cool to be smart. Welcome to our PET interactive simulation. Today, I will show you a virtual experiment regarding the relationship between wavelength and wave frequency. I prepared and arranged the settings of our PET simulator so that we can just immediately proceed with our experiment. In this activity, we will establish the relationship between wavelength and wave frequency. To start, focus your attention on the screen. This string will make some waves by controlling the FET simulator. Initially, let me press the play button and observe for a while as the string makes some waves. As I pause the simulator, from point A to point B is the wavelength of the string. Now, showing the ruler and measuring the wavelength, it appears to be approximately 4 centimeters. I would like you to notice that this measurement has resulted from the frequency of 1.50 Hz. Now, let us press the play button and try to increase the frequency from 1.50 Hz to the maximum rating, which is 3.00 Hz. As you can see on your screen, this manipulation has obviously resulted in an increased frequency of the waves. How about the wavelength? Let us once again pause the simulator and measure the wavelength after increasing the frequency. What is the wavelength now? Correct. The wavelength has become approximately 2 centimeters. This time, let us go beyond 1.50 Hz and set the frequency lower to exactly 1.00 Hz. Let us press the play button and observe what will be the resulting wavelength. What is the new reading of wavelength after lowering the frequency? That's great. The answer is approximately 6 centimeters. I have organized the result of our experiment in a tabular form. As reflected in the table, a frequency of 1 Hz has resulted in a wavelength of approximately 6 centimeters. Increasing the frequency to 1.50 Hz will result to a wavelength equal to 4 centimeters. Finally, a wavelength of 2 centimeters resulted from a frequency of 3.00 Hz. Did you enjoy the experiment? Great! I am pretty sure now that you have already developed an idea regarding the relationship existing between wavelength and wave frequency based on the recently performed activity. Hopefully you enjoyed and learned new things from our discussion. Again, I am Ma'am Azeneth A. Romero saying, it's always good to be smart. Stay safe always and see you around.
Based from the experiment, wavelength and frequency of light are inversely related. The higher the frequency, the shorter the wavelength, and the lower the frequency, the longer the wavelength. On the other hand, the energy of a wave, which is the third characteristic, is directly proportional to its frequency, but inversely proportional to its wavelength. That means, the greater the energy, the greater the frequency, and the shorter the wavelength. Given the relationship between wavelength and frequency, short wavelengths are more energetic than long wavelengths. Discussing further, let us now describe the 7 types of electromagnetic waves in accordance to their wavelength, frequency, and the amount of energy they carry. Before that, let me explain to you first on what is electromagnetic spectrum. Do you have an idea on what the electromagnetic spectrum is? The electromagnetic spectrum is a continuum of electromagnetic waves arranged according to frequency and wavelength. It is a gradual progression from the waves of lowest frequencies to the waves of highest frequencies or vice versa. According to increasing frequency, the EM spectrum includes radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. These waves do not have exact dividing regions, meaning to say, we cannot precisely identify where one EM wave starts and where it is supposed to end. To make it clearer, let us observe this illustration. This illustration contains information on the 7 types of electromagnetic waves and their respective characteristics based on wavelength, frequency, and energy. Specifically, This image shows the relationship of these characteristics that corresponds to individual EM waves. For example, gamma rays and radio wave are positioned on the extreme ends of the spectrum. This only means that each of them possesses features that are entirely opposite of the other, while the remaining 5 are located between the two, which means these are arranged following a specific configuration within the spectrum. This time, let us identify each of the 7 types of electromagnetic waves based on their properties and uses, starting with radio waves. Radio waves has the longest wavelength in the electromagnetic spectrum. Because of this, radio waves is known to have the lowest frequency and carry the least amount of energy among all the types of EM waves. It is produced by making electrons vibrate in an antenna. Low-frequency waves, just like radio waves, are suitable for communication over great distances. It is used to transmit sound and picture information covering vast locations. Radio waves has a wide range of wavelengths. The whole region of the radio waves is divided into small region or wavebands. Each waveband is allocated by the law to a specific radio or broadcast service. Let us now proceed with the second type of electromagnetic wave, microwave. Microwaves can penetrate the atmosphere of the Earth and have smaller wavelengths than radio waves. This is the reason why they are used for satellite communications. Communication satellites travel around the Earth at an altitude of 35,000 kilometers above the equator. Microwave signals are transmitted through antenna to a given satellite, which amplifies and retransmits a signal through antenna in other parts of the world. This is how communication happens over vast distance across the globe. Microwaves are used to transmit television news coverage from mobile broadcast vehicles back to the station. The news crew can also set up a small antenna to send signals to a communication satellite. This is how news is broadcasted and watched live around the world. The following are only some of the other uses and applications of microwaves. A cell phone is a radio transmitter and receiver that use microwaves. Cell phones depends on an overlapping network of cells or areas of land several kilometers in diameter. Every cell has its own tower that receives and sends microwave signals. Microwaves have short wavelengths and are reflected by small objects. This property is used in radars. Radar is the acronym for radio detection and ranging. A radar system consists of an antenna, transmitter, and a receiver. The antenna whirls around continuously to scan the surrounding area. The transmitter sends out a narrow beam of microwaves in short pulses. A distant object reflects some of the signal back to the receiver. The direction to which the signal was received gives the direction to the object. The distance of the object can be calculated from the time lag between the transmitted pulse and the reflected pulse. The last use or application of microwave in our discussion is perhaps the most common, and this is the microwave oven. In a microwave oven, food efficiently and intensely absorb certain microwave frequencies. These microwaves easily penetrate the food being heated. This process agitates the water molecules within the food, thus creating molecular friction, which then produces heat. Electromagnetic waves are truly fascinating products of nature. For the meantime, let us have a short break, and later, we will continue discussing the remaining types of EM waves. So, Do not change the channel and we will be right back.
Maya po oras kaya kayo, Fernandinos. Ako pala ay Elwin Arl Serrano ng City Tourism Office ng Siyudad San Fernando. Ngayong bulan na ini, pagmasusyantaya ang National Heritage Month na ating temang Victory and Humanity, Upholding Filipino Heritage and Identity. Kambena nini, metong karang aktibidades na ng siyudad, apin ng launching ng bayong Heritage Passport. Yung Heritage Passport, apin ng metong karing proyekto ng kakatamong siyudad, yung pamanamuna ng Mayor Edwin D. Santiago. Anong nuka rin makalagelangan ding eganaganang heritage sites, heritage structures, naakit tamo kin kay katamong heritage district. Makakayado din kini, ding importansya da ding mapil na tradisyon kay ni syudad, kalupa na ning pamangawang parol, ang po yung pamangalesa. May awo siyang heritage passport, uling atin kang dapat gawan, anong nukaran puntalan mo la ding at yung passport, at saka ka mag-selfie. Kay ba't kanta, palto making tourism office, at mamiyalang sticker ka rin eganaganang apuntulan mong lugar. At timaw may ngari ang tutong passport. Balo mi ngeni, panahon na ini, etamo makain bisa lumal, uli na ng COVID-19 pandemic. Kaya naman kimbanwa ngayon agkatan ko la ding bikers tamo, edad 18 hanggang 50, imbis na lumaot kayo po, di na nyo lang dita ka oras di kaya katamong heritage structures, kaya ni syudad. Anya naman karing mumunang 50 bikers ang makayari kaya katamong heritage passport, midinan lang premyong only San Fernando loot bag. Inggawan nyo mo bakanta makapag-register, munta kayo mismo opisina na ng City Tourism, king munisipyo, at saka kayo magdalang metong valid ID. Kabinan ng kaya kayong heritage passport, ating makasipit ang instruction nung nano pa ing dapat gawan. Anya naman ka rin hanggang kapadyakin, nanano ko pa, tara na!
Fernandino Teens TV.
Welcome back to Fernandino Teens TV Season 2. Earlier, we started discussing the properties, characteristics, and uses of EM waves, particularly the first three on the lower end of the electromagnetic spectrum. To continue, let us now give emphasis on the remaining types includes infrared, visible light, ultraviolet, X-ray, and gamma rays. Infrared radiation lies beyond the red end of the visible light and is emitted by all objects. The amount of energy and wavelength of radiation depend on temperature. Below 500 degrees Celsius, an object emits only infrared radiation. Above 500 degrees Celsius, an object glows and emits both infrared and some visible light. Our bodies emit infrared radiation, and under infrared camera or a night vision goggles, our images appear in variety of colors. The differences in colors corresponds to disparities in temperature. For example, shades of blue and green indicates region of colder temperature, while red and yellow indicate warmer temperature. This application of infrared is remarkably useful during this time. Airports and other establishments have installed devices that can accurately detect the temperature of people, therefore preventing the entry and exit of suspected COVID-infected individuals. Lastly, remote controls used in TV sets, video players, and other appliances function through infrared radiation. The next is visible light. Visible light is a form of electromagnetic radiation just in between infrared and ultraviolet. Generally speaking, visible light is defined as the EM wave visible to most human eyes. Our eyes are sensitive to electromagnetic waves of wavelengths that range from 4 times 10 raised to the negative 7 meter to 7 times 10 raised to the negative 7 meter. This is the range of wavelengths of white light. Thus, the spectrum of white light is therefore called the visible spectrum. When white light passes through a prism, it's separated into its constituent colors: red, orange, yellow, green, blue, indigo, and violet. These colors do not distinctly separate, but they continuously change from red to violet. Red color has the longest wavelength from among these colors, and violet has the shortest wavelength. This table shows the relative wavelengths in nanometers of the 7 colors of visible light. As you can see, violet and indigo have the shortest wavelength among the 7 colors of white light or visible light. This means that these 2 colors have the highest frequency and carry the greatest amount of energy. On the other hand, the red color has the longest wavelength. This means it has also the lowest frequency and the least amount of energy among the constituents of the visible spectrum. The next type of electromagnetic wave after the visible light is ultraviolet or UV radiation. Ultraviolet radiation lies just beyond the violet end of the visible spectrum. Ultraviolet waves have shorter wavelength than the visible light. It also carries more energy. The sun is our main source of ultraviolet radiation, but there are also artificial sources of UV light. Ultraviolet radiation in UV lamps are used by banks to check the signature on a passbook. The signature is marked on the passbook with fluorescent ink. It becomes visible when viewed under ultraviolet lamp. These lamps are also used to identify fake money or banknotes. Ultraviolet radiation is also used in sterilizing water from drinking fountains. Some laundry chemicals, such as the blue powder locally known as tina, also contain fluorescent compounds, which glow under the sun. These make your shirts look whiter when exposed in daylight. Ultraviolet radiation in sunlight activates the vitamin D present in the skin and gives us a tanning effect. However, since UV rays carry a great amount of energy, it could become harmful to some extent. It could actually burn the skin and hurt our eyes. Overexposure to UV radiation may cause skin cancer and other skin diseases or disorders. Suntan or sunscreen lotions serves as filters in order to protect our body from the damaging effects of ultraviolet radiation. Before we continue with our discussion, let us answer this riddle first. Are you ready to hear the riddle, Fernandino teens? Great! The riddle goes like this. If you have badly hurt yourself and you're letting out lots of groans, doctors might use this special scan to see if you have broken bones. What am I? If your answer is X-ray, you are definitely right. X-rays come just after the ultraviolet rays. They are of shorter wavelength but carry higher energy than the UV. X-rays are produced using an X-ray tube. They are emitted when fast-moving electrons hit a metal target. X-rays were discovered by Wilhelm von Röntgen in 1895. Long wavelength X-rays can penetrate the flesh but not the bones. They are used in X-ray photography to help doctors look inside the body. They are useful in diagnosing bone fractures and tumors. Short wavelength X-rays can penetrate even through metals. They are used in industry to inspect welded joints for faults. All X-rays are dangerous because they can damage healthy living cells of the body. This is the reason why frequent exposure to X-ray should be avoided. At the same time, pregnant women are not supposed to be subjected to X-ray procedures, since too much exposure to X-rays can damage bodily tissue and abnormal development of the baby. As such, frequent exposure to X-ray may also cause cancer. The last type of electromagnetic wave is gamma radiation. Gamma rays lie at the end of the electromagnetic spectrum, opposite to radio waves. They are shortest in wavelength and highest in frequency. They also carry the highest amount of energy, thus, they are more damaging and dangerous. Gamma rays are emitted by stars and some radioactive substances. Because of this magnitude of energy, it can only be blocked by some metals, particularly lead and thick concrete. Gamma rays are extremely strong that they can kill living cells. Regulated intensity of gamma rays are used to treat cancer through the process called radiotherapy. They are also used for sterilization of drinking water. After discussing the properties of each of the 7 types of electromagnetic waves, let us consider these additional and important points. Number 1, most EM waves are invisible to the eye but detectable. Only the visible light is seen by humans. Number 2, waves in the EM spectrum includes the following from the longest wavelength to the shortest wavelength: radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, gamma rays. Number 3, this order also shows the increasing frequency and energy of the EM waves. Number 4, the waves in the various regions in the EM spectrum share similar properties but differ in wavelength, frequency, energy, and the method of production. Number 5, the region in the EM spectrum have various uses, applications, and consequent effects as follows. Radio waves used in television and radio communication. When absorbed in large amounts by the body, it can produce heat, which then leads to burn. Microwaves, applied in satellite television and communication, can heat body tissue the same way it heats food. Exposure to high level of microwaves can cause a painful burn. Infrared waves, used in remote control and household electrical or electronic appliances. Prolonged exposure to infrared radiation causes a gradual but irreversible dullness of the lens of our eyes. Other forms of damage to the eyes from infrared exposure include scotoma, which is a loss of vision due to the damage of the retina. Even low-level infrared absorption can cause symptoms such as redness of the eye, swelling, or hemorrhaging. Visible light, used as artificial lighting, also applied in optical fibers in medical uses and screen of electronic devices. The visible light radiation can exert different biologic effects such as erythema, pigmentation, thermal damage, and free radical production. Ultraviolet use in sterilization and fluorescence. Exposure to UV rays can cause premature aging of the skin and sign of sun damage such as wrinkles, leathery skin, liver spots, and solar elastosis. UV rays can also cause eye problems. They can cause the cornea on the front of the eye to become inflamed or burn. X-rays are utilized in medical use and engineering applications. While X-rays are linked to an increased possibility of cancer, there is a low risk of short-term side effects. Exposure to high radiation levels can have a range of effects such as vomiting, bleeding, fainting, and hair loss. Gamma rays mainly used as part of medical treatments. Gamma rays can pass completely through the human body. As they pass through, they can cause ionization that damage tissue and DNA. As we have discussed, electromagnetic waves have countless uses and applications. Truly, the present technological advances will not become possible without the presence of these EM waves. Prepare your ball pen and paper because when we return, we will test your understanding regarding the concepts that we have just taken. Do not change the channel and we will be right back after a short while.
Hindi lamang sa larangan ng pangkabuhayan apektado ang maraming pamilyang Pilipino, kundi maging sa larangan ng pagkatuto ng bawat batang Pilipino. Inilunsad ng siyudad ng San Fernando ang programang Nurturing Environment and System for Thriving or NEST, isang education community pantry na naglalayon para sa isang malawakang pagtulong, paglantabay at paggabay na ang focus ay ang makapagbigay ng tulong at suporta sa ating mga mag-aaral sa pamamagitan ng pagbibigay ng educational needs gaya na lamang ng school supplies, tutorial sessions, study tips, at iba pang mga pamamaraan na mas lalong makatutulong sa pag-angat ng ating edukasyon. Dahil hindi hadlang ang pandemya sa magandang kinabukasang naghihintay sa ating mga mag-aaral. Sino-sino nga ba ang mga kalahok sa programang ito? Sa pagtutulungan ng ating school administrators, guro, magulang, at iba pang mga miyembro ng ating komunidad gaya ng barangay officials at sangguniang kabataan ay siguradong magiging mas matagumpay ang programang ito. Paano nga ba ang magiging proseso ng naturang programa? Una, magkakaroon tayo ng isang Facebook group, ang Pampanga High School NEST Education Community Pantry na pangungunahan ng Educational Pantry Coordinator. Ang mga magulang, tagapangalaga at mga guro ay ia-add ng ating Educational Pantry members sa Facebook group na ito. Sa page na ito maaaring i-post ng mga magulang at tagapangalaga o sino mang miyembro ng Educational Pantry ang kanilang mga kahilingan o requests. Kailangan ding ilagay ang pangalan ng mag-aaral, grade at section para sa mas agarang aksyon. Oo nga pala, hindi lang requests ang pwedeng i-post. Pwede ring mag-post ang mga nais magbigay ng tulong o mga gustong mag-donate. Sabi nga nila, sharing is caring. Tandaan na ang Facebook group na ito ay pribado at posts na may kaugnayan lamang sa page na ito ang maaaprobahan. Mayroon din palang Google Form na ipamamahagi kung saan maaari nating isumite ang ating requests o kahilingan. Paano naman ang mga walang internet access sa bahay? Huwag mangamba dahil merong mga nakalaang drop boxes ang ating paaralan na kung saan maaaring ihulog ng mga magulang at tagapangalaga ang kanilang requests. Sa mga nais namang mag-donate ng school supplies, maaaring ilagay ang mga ito sa tabi ng drop boxes. Maaari ring mag-donate ng mga kagamitan o cash donation kaakibat ang pagsusumite ng deed of donation form. Pangalawa, mahalaga ang ugnayan ng mga guro at ng mga magulang o tagapangalaga sa programang ito. Gamit ang video calls o chats ay ipahahayag ng mga guro ang adhikain ng programang ito sa mga magulang o tagapangalaga. Maaari ring gawin ang orientation na ito ng face-to-face kasabay ng schedule ng kuhanan ng mga module. Gaya ng nabanggit, hindi lamang mga bagay ang maaaring i-donate. Pwede ring mag-conduct ng tutorial session, study tips, at iba pang mga kagamitan sa pagkatuto gaya ng mga aklat o kaya ay gadgets. Ikatlo, ang requested needs ng ating mga magulang o tagapangalaga ay ililista ng ating NEST focal person. Ang mga coordinator naman ang mag-aayos ng mga ito. Ang advisors ng ating mga mag-aaral, guidance counselor, at iba pang mga guro ay ipaaalam sa ating mga magulang at tagapangalaga ang petsa at oras ng pamimigay ng requested needs na gaganapin sa paaralan. Sabi nga nila, it takes a village to raise a child. Kaya naman aktibo at iba yung pakikilahok ang inaasahan sa pagsasanib puwersa ng paaralan at barangay na siyang tutukoy sa pangangailangan ng bawat Fernandinong mag-aaral at kikilos upang matugunan ito sa tulong at suporta rin ng mga miyembro ng komunidad. Isang malawakang komunidad para sa isang produktibong educational community pantry ay tiyak na lilikha ng iba yung pagkilos upang maging mas magaan at madali ang pagkatuto ng bawat kabataang Fernandino. Kaya naman tandaan, magbigay ayon sa kakayahan, kumuha ayon sa pangangailangan.
Fernandino Teens TV.
Welcome back, Fernandino Teens. We are done discussing the properties, applications, and consequent effects of electromagnetic radiation. As I mentioned earlier, we will conduct an assessment to test your understanding on the topics presented. Are you ready to answer, Fernandino Teens? Awesome! Let us start. Number 1. Which of the following is the correct order of lowest to highest energy? A. Infrared, radio wave, gamma rays. B. Microwave, visible light, gamma rays. C. Ultraviolet, visible light, gamma rays. Letter D. X-rays, visible light, microwave. Good job, Fernandino Teens. The correct answer is B. Among the three, the microwave has the lowest energy, while gamma radiation carries the greatest amount of energy. Number 2. The electromagnetic spectrum can be expressed in terms of energy, wavelength, and frequency. A. True. B. False. Great! The correct answer is true. The electromagnetic spectrum in general can be described or measured by its characteristics such as energy, wavelength, and frequency. Number 3. Which among these types of electromagnetic waves has the lowest energy? A. Gamma rays. B. Ultraviolet rays. C. Visible light. D. X-rays. Very good. The correct answer is visible light. Visible light can be found in the middle portion of the electromagnetic spectrum, while the remaining choices are located at the extreme end. Number 4. Which of these types of electromagnetic waves has the highest frequency? A. Visible light. B. Radio wave. C. Microwave. D. Gamma rays. Correct. The answer is gamma rays. As discussed previously, frequency and energy of waves are directly proportional. Since gamma rays possess the greatest amount of energy, then it is safe to say that it has also the highest frequency. 5. What can split white light into its component colors? A. Lens. B. Eyeglasses. C. Prism. D. Protractor. Keep up the momentum. The correct answer is prism. Prism is a transparent optical device with flat, polished surface that can disperse when white light into its component colors. Number 6. Which color of visible light has the longest wavelength? A. Green. B. Indigo. C. Orange. D. Red. Awesome! The correct answer is red. The red color has the longest wavelength of all colors of visible spectrum. Were you able to get the perfect score, Fernandino teens? Great! It only goes to show that you truly learned so much in this episode. Before we end, let me share this statement from the great Albert Einstein, and I quote, "The world as we have created is a process of our thinking. It cannot be changed without changing our thinking. If we truly desire change in our society, then let us change the way we think, starting from ourselves. Change for the better, and always be part of the solution rather than of the problem. Avoid negativity, and let us all foster optimism and harmony." These are the references in this learning episode. Again, I am Ma'am Azeneth A. Romero saying, it's always cool to be smart. Take care always, and see you here at Fernandino Teens TV Season 2.
Ganun pala. Ang electromagnetic waves ay maraming uri.
Tama. Ito rin ay maraming mabuting na idudulot sa atin, tulad ng sa komunikasyon.
Tumpak, subalit mayroon din itong negatibong epekto sa ating katawan at kapaligiran.
Ang episode na ito ay nagbigay sa atin ng mahalagang impormasyon tungkol sa electromagnetic waves.
Kaya naman, maraming salamat, ma'am.
Isa na namang makabuluhang talakayan ang ating natunghayan, Fernandino Teens.
Samahan niyo ulit kami sa susunod episode ng Fernandino
Teens
TV
Season 2,
kung saan ang kabataang Fernandino ay angat sa angking talino.
Bagong umaga, yakapin mo ang bagong pag-asa. Simulan mong abutin ang iyong pangarap na magbibigay dangal sa iyong bukas. Ang suliranin, hindi laging nandyan, dapat mong harapin. Kami iyong kasama sa bawat takin, magkaakbay nating lulutasin. Dito sa Fernandino Teens TV, ang boses mo ay mahalaga. Dito sa Fernandino Teens TV, ikaw lagi ang bida. Ang mga aral ay ginintuang atin ng bawat guro na siyang gagabay sa iyong pagkamulat. Naway umukit ito sa iyong isipan, maging mapanuri, sundin ng wasto at